Hey guys, what's going on? Mr. C here with lesson 10.8. Going to be talking about geometric probability today. It's going to be a shorter lesson, I guess just in honor of Easter. Give you guys kind of a quicker break, so it shouldn't take you too long to get today's and Thursday's homework done. So let's go ahead and jump right into the lesson. I should mention this is the end of chapter 8, just this last section, and then when we come back from Easter break, we'll be starting a new chapter. Let's go ahead and get into it. Here's our main concept for the day. Is let's say you have some region. Okay, we'll call this region like this shape. Everything in here we'll call this R. Okay, let's say you have another region that lies inside R, like this here. We'll call this region N. Okay, so we have this region here, and then we have another region R. All right. Well, I'll just leave that unshaded. Anyway, so if we have a region N and a region R, let's say you pick any point within R, okay? Okay, enclose this region. So imagine we throw a dart or something at this region, okay? What's the probability that it would land inside N? Or think about it this way. We choose a point randomly inside of R, inside this triangle. What's the probability that it lands inside of this quadrilateral N? Okay, that's what we're going to be talking about today. And so that kind of probability here, a point in R with a random position. Okay. What's the probability? It's in N. Okay, so we choose a point in here. What's the probability? It's in N. Okay, if we want to find that probability is the area of N divided by the area of R. Okay, so the one we know what's inside is R. Okay, that's going to be area. That's the denominator. And the one we're trying to figure out the probability of is N. So if we want to figure out the probability that a random point in R lands in N, that's going to be this formula here. Divide this area of N divided by the larger area of R. Okay? So let's take a look at an example with this info. I know I just kind of reiterated myself a lot, trying to come up with a good way to explain that, but let's look at this. All right, here we have a circle inscribed inside of a square. Okay, and here's what's going on. Let's say a point is randomly placed inside this square. All right, what's the probability that it's inside this shaded area and not inside this circle? Okay, seems kind of small because all these corners are much smaller compared to the circle. So if we know if it fits in this square, what's the probability that it lands in one of these shaded regions? Okay, so the way we find that is to find the area of these shaded regions, okay, add those together, and then subtract the area or divide it by the area of the square. So how are we going to find the area of this? Well, if we take the area of the square, subtract the area of this circle, right, that's going to give us what's left in these corners. So let's go ahead and do that. Let's find the area of the square. All right, square with side length 6, that's just 6 times 6, or 36, what is that, centimeters squared. Okay, and the area of the circle area of the circle, remember that is pi r squared. If this is a distance of 6, that means the radius here is a distance of 3. Or we can do pi times 3 squared, which is 9 times pi, which if we go to the calculator, okay, 9 pi is about 28.3. 28.3. Now, if we want the area of the shaded region, we said to subtract those two. So take 36, subtract 28.3. 36 minus 28.3 gives me a 7.7. Centimeters squared. Write centimeters squared here. Okay, remember I said if we want to find the probability that a point inside this square is also inside the shaded region, we take the shaded divided by the total square. So the probability is going to be, in this case, what do we say, 7.7 over 36. Okay, 7.7 over 36. Gives me about 21%. We'll round that to 21. So if that's 0.21, remember, as a decimal, 0.21 is about 21%. Okay, so that would be the probability of a point inside that square being inside the shaded region. All right. Okay, I hope that makes sense. Like I said, it's going to be a little shorter today. That was it. Go ahead and try the homework, and then it's going to be a while. It's going to be over a week till we see each other again, guys. So hope you're doing well. I will talk to you later. Peace.